All right, so our first section is experimental and theoretical probability. So just some quick vocab. You have an outcome, which is the possible results of a situation. You have an event, which is a single outcome or groups of outcomes. And then you have a sample space, which is a set of all possible outcomes. And then you have probability, which is a numerical value from 0 to 1 that measures the likelihood of an event. So from 0 to 1, meaning that it's going to be a decimal or a fraction. So this chapter, we're going to be talking about experimental and theoretical probability. So experimental means that it measures the likelihood of the event that it occurs by an experiment. And then to calculate that, you would do the number of times an event occurs over the number of time the experiment is done. And then your theoretical probability is using the mathematical reasoning behind the probability. So we're going to take a look at a few examples. So our first example, it says a quality control inspector samples 500 LCD monitors and finds a defect in 3 of them. So we have to find the experimental probability that a monitor selected at random will have a defect. So if we're setting up our fractions here, we're going to put the probability. So P of defect means the probability that there's a defect equals, and we need to put our total number that have a defect over the total number of monitors. So if we read in the problem here, we have a defect in 3 of them. So that means that my 3 goes on top because there's a 3 that have defect and out of the total monitors, which is 500. And I'm going to simplify that down to a decimal. So if I divide 3 by 500, I get 0.006 have a defect. So what we're going to have to use now, so this is going to be our theoretical probability for problem B. We're going to have to use what we got in problem A. So it says if the company manufactures 15,240 monitors in a month, how many are likely to have a defect based on our results? So our results from the experimental probability. So first we're going to have to we're trying to figure out the number of defective monitors. Now it can't be 3 out of 500 because that's only 500 monitors. Now we have 15,240 monitors. So our probability that there's a defective one is going to be the 0.006 because that's what we already figured out, that the inspector figured out it's 3 out of 500. And so then we're going to multiply that by now our new number of monitors. So we're going to multiply that by 5,240. And that's going to give us our theoretical probability, which is about, it says 91.44. So obviously a computer monitor is not a 0.44, so it's about 91 monitors will have a defect. So first you use your experimental probability to figure out your decimal, and then you use that to your theoretical probability if they give you a different number. So we notice it went from 500 to 15,000. So that means that our numbers had to change for how many were defective. Our next example is probability of rolling dice. So you have this little chart on your notes. So what you're going to do is we have to do the number of the sum rolled over the total sums. So if we look at the chart, our total sums for all 3 of these problems, if we look here, it's a 6 by 6 square, 6 by 6. And so 6 times 6 gives me 36. So that means when I roll 2 die, I automatically get 36 options. And these 36 options are all in this chart. So now we're going to look for, it says it wants a sum of 7. So what's the chance you get a sum of 7? Well, sum means add. So if you roll 1 dice and roll the other dice, what's the chance that you get 7? And when you add them together. So if you look here, if you roll a 1 on the first dice, 6 on the next dice, you get 7. 6 plus 1 is 7. Same thing, 2 and 5, 3 and 4. It also works the other way because you could have it 2 ways. The first dice could be a 1. The second dice could be a 6. Or your first dice could be a 6. Your second dice could be a 1. So there's 2 different ways that could happen. That's why they're there twice. So if we count the total, we've got 1, 2, 3, 4, 5, 6. 6 different options where we can roll a 7. And then we have to simplify down the fraction. So all of your problems you'll have to have reduced fractions. So I want you to make a note of that on your paper that you need to simplify all of your fractions. So then 6 over 36, divide the top and the bottom by 6, and that gives you 1 over 6. So you have a 1 in 6 chance of rolling a 7. Then you do a sum of 4 it's asking for. So still our total rolls, because whenever we have 2 dice, it's always going to be 36 on the bottom. That'll be our total. And then we're going to look for where is there a sum of 4. So sum of 4, I'd have to roll, let's say, a 2 and a 2. That would give me 4. And then the only other option I have is 3 and 1 or 1 and 3. And those 3 options would give me 4. So 3 out of 36 is my chances for rolling a sum of 4. And again, simplify your fractions. So 3 divided by 3 is 1, and 36 divided by 3 is 12. So you have a 1 in 12 chance of rolling a sum of 4. Now for the next one, there's a sum of 13. Now if we look at the very, very corner, our highest number, if we do 6 and 6, 6 plus 6 gives me 12. So there's nothing else higher that I can roll than a 12. And 13 is greater than 12, so there's no way, it's impossible for me to roll a 13. So that is a 0. So there's a 0 divided by 36 is 0. So there's a 0% chance that I'm going to be able to roll 13 with 2 die because dice don't even add up to 13. And then our last example, it says that we have a jar that contains 10 red marbles, 8 green marbles, 5 blue marbles, and 6 white marbles. What's the probability of randomly selecting marble that is not green? So again, we have to do our probability of it not being green. So we're going to put our not green marbles, which is what we're looking for, over our total marbles. And then we're just going to plug in the numbers here. So if we look at our total numbers, I've got 10 red, I have 8 green, so I'm going to put 10 plus 8, plus I've got 5 blue and 6 white, plus 5 plus 6. That's going to be my total, and that gives us 29 on the bottom. And then it says not green, so that means I'm going to use all numbers except for the green ones. So 10 red, so I'm going to put 10. I can't put 8 because 8 goes with it's the green marbles. Then 5 is blue, so that's not green as well. And then 6 is white. So then I have 21 over 29. So that's your probability for pulling a not green marble.